Hello everyone. Thanks for having me to be part of this amazing conference. I am Aziz Yazit. I am UI developer from Malaysia. Currently, I work as a software architect where my main role is leading the design system and the component library. Today, I will talk about the component patterns and technique. I will talk about the 3LC. The 3LC stand for the three-level components. And what I mean by the level component is the component level in your organization component structure. In the most modern component structure, we have the design system on the top, followed by the component library and the product and application that use the component from the component library. I start my career in UI development by providing the UI plugin. And then we start to, from the plugin, develop the widget. And the main difference between the widget and the plugin is an individual UI building block, while the widget is the group of UI building blocks. And then we start to develop the single page application by using the application scope framework, like the Backbone.js, EXT.js, and also Ember.js, and so on. And this framework offer us to use the most serious architectural style like the MVVM and the MVC. The MVVM stand for the model view model, and the MVC stand for the model view controller. At this point, the reusability is always on the limitation because we doesn't have an idea how the reusability should work in this application, how we want to reuse the element and the resources. When the Google introduced the Angular JS, finally we have an ability to create an external module outside of our application scope, and to use this external module we just need to inject into our application module. And the rest of the application in our organization that been built by the Angular JS, this external module is available for them to use. When the Alex Russell introduced the web component, if I'm not mistaken, on 2011, finally people see the new UI architecture, the component-based architecture. The component itself is self-contained UI that is isolated and encapsulated to prevent the side effect from the outside to the inside. And they also prevent the side effect from inside to the other component, as all the code is belong to the component itself. And the component is composed of another component, which is that we build the component by combining or composing the component with the other component. For example, if I develop the accordion components, the accordion component is composed of the accordion header, the accordion title, and the accordion content. Same thing with when we develop the card component, it consists of composed of the card header, the card actions, and the card body. And the component-based architecture establishes the most used component level or the component structure, where we have the design system on the top, which is the design system is provide the collection of basic reusable components guided by the standards that can be assembled to build a numbers of application and products. And followed by the component library, where it implement the component from the design system and provide or customize it into the organization components. And then the product and application that use the component from the component library. The live example about the level components is in the context of the Google as an organization, where the Google use the material design as a design system in their organization. And then they have the Google itself have a lot of product, and each product have their own component library, which is the consumer of the design system component. For example, Firebase have the component library, the Firebase component library, the Google Cloud component library, and Google Drive component library, and so on and so on. And if we take an example of the Firebase component library, the consumer of that component library will be the Firebase for the admin web applications, and Firebase for the user web application. Some organizations prefer to use the less level abstractions or less level component. For example, they like to use the two-level components. By doing this, they'll be able to minimize the level of abstractions because the product and application is the direct consumer of the design system. But in the context of today applications, the application can be a workspace or the projects that can have the multiple app or the multiple site. For example, think of the user app and the admin app inside the same workspace. Or in the e-commerce, usually they have the storefront app and also back office app inside the same workspace. So that it's not that the rule that less abstraction is the better. It's always rely on the context of your organization, team, and your product. So that when having this kind of the structure where you have the multiple app inside the one workspace, it's a common to have another level of abstraction on top of this application and products. And this level of abstraction is the component library that will be reused by all of the application inside the same workspace. As the considered the positive return value that been return value for component reusable across the applications, then it is the win-win situations to have this new level of abstraction in your component level. We have discussed about the less level component, and now let's talk about the more level component. As we said before, that a less level component doesn't mean that it's the better. Is that concludes that the more level component is the better? Yes, my answer is no. It's always depend on the context of your organization, your product, and your team. Some team, they prefer to have to come up with to develop the application in the complex architecture, for example, the micro front end. And especially this is happen when you have already the back end that been developed by the microservices. And it's common for the front end app to be developed in the micro front end when you have the back end and the system behind is in the environment of the micro front end. So the structure or the corporate level in four-level company, usually they start with the design system, where this design system only provide the base and the basic things and the atomic component. What I mean by the atomic component is like a simple component like the button, checkbox, radio, etc., etc. And this atomic component will be shared across all the team. And then after that, the next level is also the design system, but this design system is team-specific design system, where they have their team-specific basic components that only been used in respective team, and also that they have their own team-specific style guide, standards, and conventions. And then after that, they have the component library, and this is a reusable component library that been used by the application and product. By having the multiple design system is a mesh or is effective for the self-dependent team and autonomous team, which is usually the front end consists of this kind of team. But for having the consistent and standardized component become even the job become even harder, because we have multiple design system, multiple standard and conventions. But in some contexts of an organization, this kind of structure is effective and practical for them. So in our talk today, our main focus is three-level component, and the reason is because this is the most used component level by most of organizations in the context of today applications. So we have the design system on the top, which is the first level of abstractions, and then we have the component library as the second level abstraction, and then we have the product that use the component of the component library. So in the third level, we choose to use the least power solution, where at this point we just reuse the component and configure the component. Abstraction is cool, but it must be balanced with the principle of least power to avoid the wrong abstractions. In fact, if the people who are suffered from the wrong abstraction, if they can turn back to the initial starting point, they will choose the least power solution. For example, they might prefer to provide the duplication code over an abstraction because the duplication is far cheaper than the wrong abstractions. The chronology to the sunk cost fallacy is that the developer hate to see the duplicate components, and then he starts to refactor the duplicate component into the new reusable component. Guess what? That's create the new abstractions. And then the new design requirement come, we added the new variant into the abstractions, and the universal abstraction now behave differently for different cases. The process will be looped, and until the code becomes incomprehensible, and that is where you might be trapped into the sunk cost fallacy. The sunk cost fallacy is whereby a person is reluctant to abandon a strategy or course of action, even though the abandonment would be more beneficial, as you don't want to lose out on the effort that you have already sunk, the effort that cannot be recovered, and you keep on invest on the wrong path, even though you know it's wrong. A lot of problems arise from the bad understanding where we should be in the level of abstractions. And that is where we have the 3L-C that have the technique for the each level. The first level technique is called compounding, where it provides the compound component to the second level to implement it. And that's why the second level called implementing, where we implement the compound component, customize it, and provide the pre-built component with designs and styling ready to be used by the third level component, where the process to use and configure is called configuring technique. The compounding is the technique where we need to have the mindset of develop once and use forever. Develop the component once and use it over and over again. So what I mean by the use forever is the component needs to be relevant over time. When we have the new project or the new applications, this component can be used in those new project and the new application. And this is possible as long as we be able to extract away the UI behavior and UI logic and provide the very minimal user interface that will give the maximum flexibility for the second level to decide on how the components to be looks like. And if I think back on my own experience in the UI development, I have almost 8 experience. I keep on creating the same component over and over again. I would say that I might create the select component 10 times. Even though they have the different in terms of the visual and the design, but the UI behavior and UI logic is always the same with all the 10 of the select component. That's why at this stage we try to extracting away things that will never change, and this abstraction will be valid over time. In the compounding technique, we use heavily the pattern called compound component pattern. The compound component is a pattern in which components are used together, such that they share an implicit states that lets them communicate with each other in the background. So the implicit state will be managed by the parent components, and the interaction inside the children, which is will be inside the container of the parent components. Those interactions with like the component being clicked, the component being hovered, etc., those state will be updated into the parent components, and updated state will be shared across the components or the children component of the parent component. Think of the compound component like the select and the option element in HTML. Apart, they don't do too much, but together allow you to create the complete experience. When we go check on the source code of the design system component, for example, the ng-0 select component, we did see that the component has been chunked into the individual components. They have many children as individual components, and this gives the flexibility for the consumer of the select components to implement the select component into numerous way or numerous look and feel. As an example, in the screen right now, we have the first one, the select component with the autocompletes. We have the select component that have the customized selections, selected display as blue one, etc., etc. So back to the diagram about how the parent component manages the implicit state to give the components or the children of the select container components be able to communicate. In this context, we will use the select components. For example, we have the select container component as a container for the children, and inside this container we have the option items as a children. And for example, imagine that we click on the option tool, then the selected index will be sent to, or will be updated to the state of the selected container component, and this selected index will be shared across the team, so that we'll be able to get the selected index, and if matched, then we can do everything on that. For example, adding the selected states, selected style, like adding the bold, and then for the components that is previously has been select, then we know that it's no longer select, then we can remove the selected style. So this is a basic example how we want to create the compound component, where we did use the ng-template outlet that receives the template, and we push the updated state into this template. And then inside this select container component, which is the compound component container, we have a lot of the state manipulator method. For example, the option click. We can have the option click, the option hover, option drag, drop, etc. And this state manipulator method will be used by the children. And the idea is that when the children be able to get the reference of the parent components, they will be able to access this option click methods, and by able to access this, we'll be able to update, change the state of the parent component. This is an example of the compound components codes. The compound component gives us an option, either that we plan to create the compound component as a components, or we can create as a directive. And the main difference between provide as a component and or provide as a directive is when you provide as a directive, it gives more flexibility for the consumer to decide on the element that will be the children of the select component. For example, for the option item, we can use the select element, or the li element, the diff element, or even the section elements. So it gives the flexibility for the consumer to decide on this. And the magic behind the implicit state that we managed by the parent is when we use the forward ref, and this forward ref, we forward the reference of the parent component, which is in this context, the select container components. And when we be able to get the reference of the parent component, then we'll be able to access the state manipulator method, for example, the option click. And this is how we manage the state between the children of the select container component. So this is the basic complete on how we want to implement the compound component. So you need to use the select container, which is the container of the compound components, and then inside there you need to wrap everything to the ng-template, because the state will be attached to this ng-template, and all the elements need to use the respective directive in order for the implicit state management to be worked correctly. So this is an example when the ng-template attached with the state that will be used by the element or by the children of the select container. So we have the is open state that will be used by the option list components to toggle the visibility of the option list. And then we can use the select options to do the customized styling of selections. For example, these two examples of the ng-zoro select components. When everything or the complicated things has been extracting away from you, which is the code for handling the UI behavior and the UI logic, in the implementing or the next level techniques, the process or the works that you need is involved on provide on the rendering part or the rendering body of each of the components, the compound component. So implementing is implement the compound components. Implement the compound component in terms of provide the custom styling, etc. And we need to have the mindset of provide the configure of a code component to the next level, which means that this component needs to be previewed with the design styling ready and can be configured by the second level. So the goal for this technique is to implement the compound components and transform into the organization's components. This is the complete example how we implement the compound component, where we use, and again, we use the select container and the templates that have all the attached, that will attach all the state that will be reused by the element or the children. And each of the element, like the span, li, central, we use the respective directive in order for the implicit state to handle or to manage correctly. And as I said before, that in this stage, we provide the configuration of a code component, which means that the product or application that is the consumer of our component will provide us the configuration object. And in this configuration object, they might have the templates, and because they might want to customize the look and feel of this component, and when we receive the template at this level, we will be pass the content of the template with the respective state in the data. And also in the implement of the compound component also involve a lot of work in providing custom style. And this is example how we provide the custom style. And this is where the decision how the component will be look and how the component will be looks, the look and feel of the component we decide at this stage of a process. So when we have done with the compounding level and also implementing level, so that in your component level or your component structure, you will have the design system on the top that provide the basics component in the compound component format or by using the compound component patterns. And the second level will implement those things, transform into the organization components, and pass the preview component that styling and design ready to be used and configured by the third level components. So when we at the first level, we're extracting away the work of handling the UI behavior and UI logic. While the second level, we're extracting away the work for styling and design, especially on the visual and the rendering part of the components. At this stage, what we need to do is focus on the data and the business logic. So the mindset to develop this component is always about the data-driven components. This is an example of the configuration object from the product and applications, where we have the common things in the configuration object, like the label value, and we could also have the flag like disable italic underline, and we can also have even the callback, where this callback, when the action being triggered in the second level, then we can have continuing trigger the next action in the code of the product or applications. In the summary, the first level have extracting away the UI behavior and logic, and this extracting works is called the compounding technique that provide the components in the compound component format or patterns. And the second level will focusing on extracting away the visual and rendering from the next level, and provide the pre-built components that the styling and design is ready to be used and configured. And the third level, they just need to use and configure the components, so that we have balancing this component level with the abstractions and the principle of least power, especially on the third level. We don't want to add another abstraction or another component, we just use and configure. So that we come to the end of this talk, so that I would like to recommend for you to check on these two amazing talks. And this is where I make myself understand about the wrong abstractions, principle of least power. The first one is by the Sandy Mess when she talked at the RailConf 2014. The talk title, All the Little Things. We have a lot about what is the wrong abstraction, how to avoid the wrong abstraction, etc. etc. And the second one is the talk title on the spectrum of abstraction by the Cheng Lo from the Facebook, where he speak about the principle of least power at the Rio 2016. So later after this talk, I will put the link, the step list link in the chat so that you can play around with the code. The code will be consist of the first level compounding and the example of implementing and the example of configuring. So they give for you, all of you, chance to play around with the techniques in the step list. So thanks for listening my talk. Stay safe, everyone, and bye.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.